right. We are live. We are live. We are back. Real Science episode 40. We've got Xirtus. We've got Simon C. We've got Exotic Propulsion, aka Jeremiah Pop. We have the lovely Liminal. We have Space Queso Adam. We have Rayo, aka Liberty Under Attack, aka the Vanu Podcast. We have Phil Bouchard as well. And somewhere should be Thomas. Maybe he fell asleep, but he should be here at some point.
Well, how are you?
I'm good. I just got great news that I don't have to move my storage unit anymore, so I can start traveling to all these ancient megalithic sites that are around Alberta and do more things.
And Liminal, are you still in here? Yeah, you are. I see you. How you doing?
Yes, I am. I'm here for the fun today. I uploaded some old but fun little science bits that Jeremiah or me and Jeremiah did back in the day. So
sweet. Jeremiah, what about you? How you doing? He's like, I'm not telling.
I think he's currently setting up one of his experiments.
Don't put yourself in a danger.
Yeah, my apology. I just stepped away for a minute, but yeah, I just tested the microwave transformer with the vacuum chamber, and we do have these little flickering kind of sparkly events happening on the end of the copper wire, and you can clearly see their exotic vacuum objects. So we'll show those live in a bit later in this show.
I'm looking forward to that. And Rayo, what's up? How you doing, man? You're muted though. So
yep. There we
go. You can unmute,
okay,
or
I'm
you
muted
can
now.
stay muted and pantomime how you're feeling. It's totally up to you. But what's up?
Oh, things are good. Things are good here at Pasnea, and yeah, great to be with all you guys, and looking forward to some real science tonight.
Sweet, super stoked. Space Case, Zero, how you? I don't know. I'm putting everybody in a hot potato situation. Good. Yeah. Sorry. What's up? How you been? It's been a minute.
Oh, I don't know. Wheel bearing failed on my car. I've been fine. I don't know. Various things.
Space
going
Case,
on.
your mic is really low right now for some
And
reason. But it was
I
great
just
to
got
see.
word. Sorry, I just got word from Thomas. And is there any way Liminal and Jeremiah you're able to share a mic? Otherwise, we are maxed out. I don't even have a Bert and Ernie homunculus to get rid of at this point.
I mean, if she wants to show these things that she's got preloaded, let's just air those and then kick them out because we only have the 10 slots. So.
I'm sorry. Is there too many people on?
No, there's just too many slots for preloaded videos, and we.
Oh yeah. I can just show some of these and get rid of the slots. So,
is that what's going on? Okay, I get it now. I can't see the other side.
I just need to be approved to show the video. I want to show the one where Jeremiah created a ferrofluid film. Yeah, there we go. It's real short, so keep your eye on it. That is a magnet underneath.
So this is the classic WD-40 and small ferromagnetic iron particles. And they are rod-shaped iron particles, which is part of the key structure of the ferrofluid cell, or the ferrocell, as our terrible associate has mentioned.
This is probably my favorite way to visualize a magnetic field.
Yes.
It is amazing, but here's the thing. Like, we see these lines. I want to just clarify, and unfortunately, Thuria did not clarify this, or Ken Wheeler. These are individual points of LEDs, so each one of those lines that you see is coming out of the center of the phosphorus matrix of the LED, and they are not actually the count or quantity of lines coming from the magnetic flux, but that's actually the number of LEDs that you're seeing. Each one of those lines is from one individual LED. It's not a direct effect of the magnetic flux. So that doesn't mean that as many as you can count, there are that many magnetic field lines. There are an infinite number of field lines, and every single one is associated directly with an individual nuclear magnetic moment of the atomic lattice, directly associated with the electron valence shell, which means there are trillions, although we can count them on one hand because we're only using a small quantity of LEDs. He doesn't specify that. I'm telling you guys now, that's what's really going on.
Welcome, Thomas. Good to see you.
Glad you could make it.
What up, guys? Full party in here, man.
It is. We got the full panel for real science going on tonight.
Glad you made it.
The portal.
I can't miss my science lesson, man. I already got too much homework that I need to get caught up on.
Yeah, now that you show that, Bernie, can you remove those from the stream so we can open slots?
Sorry, which one? I removed the
I
one.
removed one.
Shows them.
We're good. We got Thomas. Thomas made it. We're good. So what you have up right now?
Is it okay if I show the other ones?
Yeah. Absolutely.
Yes,
we
yes,
are
you may.
perfect.
Here's let's see if this plays. Something trippy for y'all.
So this is a homemade kaleidoscope.
So she comes to me one day and says, I want to recreate the Star Trek, star field effect, and I want to do it analog with physical devices. So she takes pieces of back reflector, or I should say first surface mirror reflectors from the inside of a rear projection TV, and she maxes it out on a piece of paper and draws up exactly where she wants to draw her star field. What she ended up creating by scratching through the silverized coating of these pieces of glass is exactly what she had on the piece of paper, and I was completely amazed.
So this is analog. This isn't a digital creation. This is a recorded.
Absolutely not.
Yeah, this is completely analog. This is like
that's so cool, man.
I also built the light. I also built the lighting plots. Yeah. The lighting I built as well. So this is all analog.
So I'm going to ask for the audience. You're going to upload this to YouTube or somewhere so we can watch it in like higher resolution and frame rate, right?
There you go, Liminal's first video. Come on.
Or you could just hit that share with audience right now and make your first video. Look,
I would like some
American.
I would like some 4K though, so like Thomas and I could write like some crazy sci-fi time tunnel kind of thing. Time tunnel means Logan's Run.
Dude, we could run that through Stable Diffusion too, and get it to like conform to different shapes, but like retain the colors and the patterns.
Dude, he's always trying to convince us that he can get AI to conform.
Gatekeepers are
this was originally recorded in 4K.
Past.
It looks a little bit compressed on the social media stream. Yeah, this was originally recorded in 4K, but it unfortunately just comes out looking a bit compressed on the platform.
Pretty rad.
Just a bit of background information on this. We've gone to like live rave shows, various music festivals, and this kind of effect when you somebody's eyes,
probably.
We've had people cry, literally cry over the visual effect that this enhances. And it has a very emotional response, which is kind of strange for me because I don't really have much emotion.
Really? Like on like a 3D map sort of projectors in full 4K or whatever the highest it goes sort of thing is what you're talking about.
MR asks what makes it analog. This is a 3-sided kaleidoscope built by hand, and only etchings or patterns were made on 2 sides. One was just straight lines, like as if you were watching Star Trek going into warp, and the other one, the other side that had a pattern on it, was just a bunch of dots, like a star field. So right now it's illuminating the star field.
So one day she came up to me and she's like, I want to recreate the star field effect from Star Trek. And I said, okay, well, how do you intend to do that? And so she pulls out her notebook. And of course, in the classic liminal sense, because her own genius, she draws it up in the form of lines and uses a ruler to draw the trapezoid of how this is supposed to work. So she draws all these lines, then she takes that visually and scratches that in with a small dental pick onto the first surface mirror that this device is made of. So even though it looks like it's a round or a cylindrical tube, that's actually 3 mirrors that she personally hand carved in order to make exactly this effect precisely as her piece of paper dictated.
Like, it's not a digital graphic. This was filmed and recorded.
She built the LED
Right.
stick by hand that is producing
I
the light.
also built the smart LED stick that is illuminating what you're seeing in that video, which I'm just going to play one more time. So there's an LED light stick, smart LED light stick playing along. And then I believe I also built a small floodlight that's in the very center of the screen. So there's 2 light props going on right now. The pictures that I snapped are super sharp. The video, unfortunately, little compressed.
That's really cool. If you could project that image on a ceiling or something, I would buy you one for sure.
Actually, they did play around with that idea.
That would be a really cool
created
product.
some unbelievable effects.
With the photoluminal modulator. Yeah. Yeah, I wish
Well,
there's
that's
a
the
way
other
to
thing is
show
if you
that
use-
that people could see, you know.
If you use a photoluminal modulator, could you not send data at different rates through this flashing as well? You know, and use this for pretty interesting purposes to hold data in crystal or something.
Considering it's
transmit.
analog, you
Yeah,
really
like-
have a
And then
limitation.
Fiber optic.
You already have people in the chat who
the last one
are
I have
asking
here,
to buy some,
uploaded.
so-
This is just an example of how well you can illuminate a selenite, a natural selenite crystal. It illuminates quite well, as you can see.
Selenite's amazing. It's
There's
practically
my smart
a
LED stick
naturally
underneath the
earth-growing
glass.
fiber optic.
It's yep.
So it looks super cool, but also could be used to replace hard drives and batteries. That's kind of the. But also, you can just like set this up in your house and be like, "Dude, look at my cool hippie lamp."
I
Right.
live in an ice
So-
palace.
To be honest,
I guess the significance of the selenite
Man,
is
Sorry,
that
I have
it
to just
captures
interrupt.
light
1
very
second.
well.
This thing, the old ice castles and palaces, imagine the raves with the lasers and LEDs today.
Yeah.
but also
Be
like
happy with
go to an IBM fab processing where they have these facilities where they're trading old computers and semiconductors for photonic systems, and they're building organic crystals. They're growing crystals in order to use lasers. This all started with the G3 and G4 processors from IBM that they use in the Apple computers. They use blue lasers because they were able to focus to make a thinner laser density. So there's different kinds of laser, and in the process of shining the laser through, you're also able to grow a crystal that is built in the pattern of the laser data. So you could use this for all sorts of reasons, but it's going to be really important when you're moving away from just electricity binary dot on off towards rainbow of data, blue data, purple data, pink data, all at the same time at once, right? So you get 8 times the amount of data, 7-8 times the amount of
So
data.
then
at
we
least.
can actually understand what the different stars are saying to us in their colored light wavelengths.
But it
right?
looks like that inside the computer. And it's kind of funny because they've got a lot of people have their Pride PCs, which are like awesome gamer rainbow machines, and I love them, but they don't quite do anything yet, you know? And this is the way they're going to actually make sense.
Well, that's actually how you use GPUs for a lot of computing, is that you convert the data that you want to crunch into colored pixels, and you just modify the pixels in whatever way you need to, and then you translate that into the result.
Right. You've seen what's crazy with NVIDIA's new systems that can do in like with a 10-watt system what used to take 150 watts and all these things. Like they're moving so fast because they're using GPU systems that can focus on tensor, and they're converting everything, like you said, into color. Come on, that's awesome. That's literally Rainbow Bright's computer. That's
dreaming
And
in
what
color.
stars do. But literally what stars do. We'd be able to interpret the stars
Oh,
by
can
taking...
I please show the mercury arc lamp? It looks
yeah,
like something.
I like where you're going with
sci-fi.
this, right? Let's go full Kardashev scale. Oh, by the way, rest in peace to the World Economic Forum member who died on the submarine, who was also a member of SETI, right? Shahzada
The
Dawood?
English guy was a WEP, was he?
Jay Bloom, I don't know.
Or WEF, sorry. The World Economic Forum member.
Dawood was a member, and also he was a SETI guy. Ooh, nice. music just got real.
But we gotta mute it because
Yep.
sorry, I muted.
Yep, I know.
'cause all the
Sorry about
strikes.
that. Didn't mean to have music in there.
Or is that your music? If it's your music, we can
It's
run
not
it.
our music.
No,
She has to
it
mute it.
unfortunately
Sure.
isn't. You should mute it.
It's
All right,
Sorry about
AA is gonna
that.
start breaking down the
But,
door.
We still have to mute it.
We need Thomas. We need you working on that. It's like
I
drum
have
and
music
bass
for you,
AI
Bernie. I've
beat
got
for
plenty
us.
of tracks. I have like over 40 tracks for you if you want them. I never shared them with you.
Unfortunately, it's a
I
little
didn't know you
choppy
needed.
streaming it. Sorry, guys. Jeremiah, you might be able to give some insight to what you're doing here.
This
Yeah, so what we're doing is
setup,
we're
wow.
pumping about 580 volts through a mercury arc lamp, which is considered to be a mercury metal halide combination. And we are getting a heavy UV output into the 256 and 185 nanometer wavelength.
It's very pretty. Like that color is.
It's beautiful teal. It's an
I really
absolutely
do enjoy
gorgeous
the color.
wavelength, and it
Yeah.
also burned the living hell out of my face.
Oh yeah, you should probably not be near that.
Yeah, I found out the hard way. I mean, I didn't know what the.
You don't want sunburns like in your eyes.
Yeah, I found that out afterwards.
Yeah, I've even taken to like, hey, be careful with your eyeballs.
Yeah, the
People
eyes
thought
is
this was
weird.
part of a
Unfortunately,
time
what
machine.
this video
This is a
doesn't
pure
show
pressure
is,
endeavor.
we later achieved using a magnetic bead flux cross product across this lamp. We had a magnetic vortex which accumulated inside that same glass enclosure, and it was unbelievably gorgeous. I mean, it formed your little tornado.
Jeremiah, you know why you have to wear eye protection when you work with lasers? Because sunblock is sticky.
Well, it's not so much the laser problem; it's more so the UV exposure to the retina.
Yeah, I know.
And
That's what I mean.
it
So
turns out
but
that
you don't
your
want to put
eyes-
sunblock on your eyeballs.
Right, your eyes have this built-in feature to block UV radiation and prevent it from ever entering into the rods and cones inside your eye. But well, I didn't
How's
realize
that
how
funny?
badly the cornea would be damaged when you expose them to ultraviolet radiation in that short wavelength band.
Shame on
So
you.
I got burned pretty badly, and actually it happened just 3 days ago. Again,
Oh gosh.
this is my third exposure, and I still haven't learned my lesson because
You gotta
I'm
learn
kind
that
of a
lesson.
moron,
We could
so-
turn this into like a Fire Marshal Bill segment, maybe, if it keeps
Don't
going.
do
It's
Dude,
gonna
what
get to that point,
Jeremiah
Thomas. We're gonna
does.
be interviewed about how this happened, and we're like, "Yeah, we were just talking to the guy online, and then it started glowing blue, and then people started to worship him."
On this same note, I'm curious. What I can't remember the name of it, but there was that like movement where you would stare at the sun for like a small amount of
Yeah,
time.
sun gazing.
Sun gazing, yeah.
Sun gazing, yeah. Like, where
Yeah.
does anyone here buy into sun gazing? Because
I remember
Yeah, a
what
little
you're
bit.
talking
I like-
about. It's
I like
not a good idea.
I don't try this at home, but I think so. Thomas Jefferson was really into it, and Isaac Newton talks about it. And the idea
Really?
isn't to stare into the sun so much as at dawn and at dusk, at magic hour, you're getting that part of the sunlight. So you have to be careful as you do it because it's like right at the beginning there, and it'll be too late at a certain point. Like, but just right as like it's
Okay, well, it's like tank
setting.
armor.
There's
If
a
it's
lot of
glass
information.
flow, it's thicker. There's a lot more air that it has to go through, so you're going to get a lot less UV.
Oh,
Right?
she's
If
got
it's
Yeah.
immediately
So-
at dawn or dusk.
Yeah, so like, but if you do it like even a second too much, you're doing it the wrong time. All this stuff. So you shouldn't do it probably ever. But at the same time, feels awesome, and your third eye has like the same.
That's,
you have like a hormonal receptor.
Jeremiah's mini Tesla coil.
You're gonna have to play it again because
They do recommend you go barefoot, you ground with it because that's all part of it. There's enough information out there with yogis who have done
So there's
sun gazing,
what did you do?
meditating,
You guys
and
literally
grounding
shaved.
and fasting for years or for like a year at a time, if not longer.
Yeah,
Sort of
being
like the
barefoot.
breatharian thing.
So Jeremiah,
to
for
do.
this video, you and Pat shaved down what was it? Filings from certain metals so that you could do this experiment.
That's neodymium magnet filings that we stuck on top of the Tesla coil to produce that kind of flame effect. And so we just simply turned the thing on, and it's all Bluetooth modulated, so we're connecting with it wirelessly.
Is that the neodymium exploding into that flame plasma?
That's exactly what that is.
Fascinating. See, a lot of my
You should
coils,
try cerium.
I wrapped with iron ferrite solenoids in the center of the copper, and thus I've never hooked them up to voltage, because if you put too much in, it'll turn the iron molten and do what that's doing, right?
Yeah, look, it would. I mean, that little Tesla coil there is only about 3 inches tall, so it fits in the palm of your hand, and it runs off its own battery pack that's directly integrated into the system. You can basically pick it up and move it around and arc the stuff, so it's kind of cool.
That's
now,
brutal.
what if you did that in a microwave?
You went
We
from like
did.
Star Trek
Actually,
Logan's Run
Bernie,
to
we
RoboCop.
did
In a
do it
microwave.
And we had fantastic results. In fact, on my channel, on the Exotic Propulsion channel, I have a ball lightning experiment done live in the microwave, which, of course, is completely owned by me, so you can play it.
All right.
These are great organic effects, though,
So-
right? Like, even if you're just making this for like 70s Hollywood movies, I'm buying. Like, this is like all I need.
I want to know how far we are from a small-scale Tesla death ray. Like, can we make one at just like 1,000th the scale?
Yes,
of...
we can. We
No,
can
you
make
don't
one.
want to
I
answer
have made
that.
one.
Actually, I really
Gonna
kind
see
of
the
want to
Men in
hear the
Black
answer to that.
Yeah.
Anyone from the APF or NSA or whoever, you have to stop listening now.
The portal
You have to-
keepers, the
you have to
portal
reveal
keepers are
yourself.
jumping in.
Okay. How about vortex cannons? Is that kosher?
That's not so easy. Vortex tends to be unstable, and directing it is incredibly difficult.
Jeremiah, you
Oh, go
Go
ahead.
should
ahead.
share how the death ray works. This is the perfect opportunity.
Oh, well, okay. I can get into that. If anybody wants to know how Tesla's death ray works,
Okay.
Yeah, you know what?
Disclose that.
Kids, don't build your death rays. This is why not.
Don't do this.
This
at
is how
home.
you would
Yeah,
do
don't
it in
do this at
This
home.
is
Minecraft.
how you repel the Nazis and the evil space aliens coming for you from Project Bluebeam soon.
Hello,
Okay, so
XCOM.
the Tesla death ray is a high voltage particle accelerator that utilizes electromotive force to produce a change in the refractive index using accelerated charged particles. And Tesla's primary function, as far as his choice of material, happened to be mercury. Because, well, he knew about the ionizability of mercury. And we've already verified this in the case of a little light bulb enclosure of 2.5 inches diameter. So we verified that mercury is a fantastic catalyst to create pre-ionization of atmospheric conditions and the refractive index. This is what we did. We evacuated a enclosure that contained nothing but atmospheric gases, and then after we evacuated it, we injected approximately 1/4 size, it as in one American quarter 25-cent piece of a mercury pool sitting on the bottom of that enclosure. If you were to spin it around in your hand, it would glow against the side of the glass enclosure as you were rotating it. But what's more important here is you end up getting this particle acceleration that's a natural catalyst of mercury's ionic properties. So Tesla decided, well, what if we happen to put an incredibly high vacuum condition on the accelerated nozzle velocity of a mercury pool on an insane amount of potential? And in his case, it was 30 million volts. 30 million volts. I know that's not too much, right? It's only
How do you
30
get
megavolts.
What's that in like gigawatts?
Yeah. Well,
Actually,
this
it
is
was
when
about
like you've got
1.5
Westinghouse on
gigawatts, yeah.
speed dial, right?
So he's got this whole system set up, and he does talk about this briefly in some of the notes. And the only disclosure that Tesla ever gave about his system was at his birthday party, where he talks about his weapon to end all wars. I love that system. So and it's really straightforward. What he does is he potentializes a cupola, a high voltage terminal, using a special type of electrode, which is a vacuum enclosure Tesla lightning arrestor. And that's an umbrella-shaped electrode inside of a high vacuum environment enclosed in a vacuum. And the entire cupola is surrounded by these little electrodes. And the reason for why he does this is there are no arcs, discharges, or other corona exits from the system. So he can basically build up almost 30 million volts on this top terminal because these individual cupola-shaped or umbrella-shaped terminals are in a high vacuum environment, meaning they can't leak electrons due to the fact that you have this curvature where if you begin to increase your vacuum, I'm going to show you guys this live. Actually, I'll do a live demonstration a little bit later in this show where we increase the vacuum, and you can see how increasing the vacuum will increase the conductivity of the air up to a certain point, and then it begins to decrease or go in the opposite direction.
And is this using crystalline, or what is this using, metal? Or
it uses metal, yeah. It's conductive electrode.
Okay.
So
I'm just wondering because of like stone or for like, because can you use stone as an insulatory material if you've got metal and quartz, you know?
You can, and the Great Pyramids at the Giza Plateau have proved this quite well. In fact,
so it's like a cheap vacuum. This is stone.
Yeah, Smith proved this pretty well, and we have plenty of evidence. But I'll show you guys later on a live demonstration for vacuum.
Mica, right? Isn't mica the one they used in the Mexican ones? That's like a an insulator as well as a dielectric. Is that right?
It's a great insulator. They often use them in vacuum tubes, or at least when they started making vacuum tubes, they used a lot of mica.
So far, what I've seen is in the old 1800s notes of Steinmetz, he recommends that there are two different types of field configurations that you can generate to observe the magnetic and electric field fluxes of a system. And so we already know about iron filings under a magnetic field. We see that they form these tendrils or these types of lines where they self-align, right? But what he suggested is that there's also this electric field at 90 degrees tangential to the magnetic B flux. And so he suggests that you grind up mica to a very, very fine degree and drop that over a magnetic B flux, and you'll actually see the electric field lines forming, instead of lines, they will form rings around the magnetic B flux.
Like the torus that you showed at the beginning with the ferrofluid.
Yeah, it's very similar to that same phenomenon.
I just find it fascinating that they find mica on the outside of the pyramids and... Oop, I was muted. Find it fascinating. Pyramids have mica on the outside, mercury is on the inside, and the granite and different silicon crystal blocks, and then the calcite or limestone oolitic and the mixture. It's fascinating macro battery structures, essentially.
And how many bodies did they find in there again for a burial structure?
That's something I do not know.
That's weird.
They took the bodies, but they left the headstones, but they moved the. I forget how it goes. Yeah,
it's a very interesting story.
Yeah, it's a story.
It's a story.
They're giants, so we're not allowed to see them.
Unfortunately, we have no way to actually prove this evidence out, which means the only way for us to prove it is to do it in the lab. We have to do it under controlled conditions, and we have to replicate these types of experimental conditions so that we can demonstrate the phenomena.
Is there any simulation software that you could do this in like a virtual environment, kind of like they do with, you know, like drug interactions? They can run it through all these different simulations. Is there anything in that realm for this type of research?
There absolutely is. The problem with it is that you have to input new variables that don't currently exist in the software, and you have to program the system in order to accept these new variables. So if you don't know what the numbers are already, they don't exist in the current paradigm of our present physics. And Phil will be a great guy to talk about this, which is, he's sitting right there. So,
yeah, the best simulation software I'm aware of is SolidWorks. But you gotta hire an expert to help you out on it before there's a learning curve there.
finite element analysis. So that's like measuring mostly, how well your stuff is going to work in an earthquake, or if you put, so much
What about
power.
like the Wolfram simulation of like what are they called?
There's like MATLAB and all sorts of
Animatrons.
stuff. It's not really my cup of tea personally.
Well, we were talking about this earlier, and we were talking about ChatGPT-4 and how we need to train it, because the problem with ChatGPT is in our little private WhatsApp groups and stuff, we have asked ChatGPT plenty of times about complex physics questions, and the problem with it is that it automatically defaults to our conventional physics dogma, and it produces the exact same wrong answers as the original relativity theories. But Einstein spent the last 15 years of his life to try and convince the world that there was a new combination of electrodynamics and relativity which could solve this issue. Unfortunately, it involved Maxwell's original quaternions and a much more complicated system of field equations, which were not very popular amongst field mechanics and the mathematicians at the time. So we really haven't made major progress in that category. But the mathematics are there. There are solutions. It's just that they involve a lot more dynamic factors than we currently have available in our present physics.
So could you like back engineer it, like put ChatGPT and focus it on like a black hole or something that's like bigger than physics, or like breaks physics, or like feed it that outside data points?
I do think so. And I think that we can actually program it. I think we can train ChatGPT-4 to learn these new types of physics and look at some of these obscure or strange papers that are generally not recognized within the mainstream physics community.
Yeah, they already use AI for research in quantum physics.
I've got an idea. Thomas, if you've got it to like input into in any way, if you know how to, like start feeding it the Tic Tac, like the official ones where they're defying gravity and how they move inertia, or with less inertia in those moves, and get it to like analyze that sort of stuff.
I'm dubious on using something like ChatGPT or any large language model, because the way that a language model works, I don't know how much I would trust it to take a formula and run math through the formula versus like an actual AI that's focused on that.
I'm gonna tell you right now, if you go at low level formulas and equation, ChatGPT is not very good because it approximates mathematics. You can approximate the mathematics, so it kind of makes mistakes here and there. It gets confused easily.
Right. It's a semantic engine, so it understands what the next word in a sentence would likely be, but it's not actually doing any of the math itself.
Well, there's a really interesting video from PBS Spacetime that was released 2 days ago, which I strongly recommend to everybody in the audience. It's did AI prove our proton model wrong? Where instead of having 3 quarks inside of the the nucleus, that instead in some cases it has 5, where 2 of them end up canceling each other out. Yeah, that's why I linked it to you the other day.
I posted that article on APEC, but I didn't read it fully. But I'm gonna read it later. It's very interesting.
Well, it's really interesting because the mass of the quarks ends up being more than the mass of the proton. So
yeah, but the quarks, the sum of the mass of the quarks are not exactly the same as the mass of the proton in the first place. So there's some uncertainty. And there was a quark. They said they discovered a quark a while ago, like the pink quark or something like that. They said there were 4 quarks in a proton at some point.
Quarks multiply like Pokemon, I swear.
Yeah. So it's all like very like fluffy. The standard model is breaking apart multiple times. It's not accepting the graviton, so the graviton is kind of lagging in the background, and there are other failures with the standard model. The muon experiment. No, they said that they're at sigma 3.5 in the level of precision, but when they're gonna reach sigma 5, then the muon experiment will prove officially that the standard model is wrong. So
yeah, and I have to agree with that. Like, I wouldn't trust any results that were below sigma 5.
Do you want to elaborate first on like the muon experiment issues with the muon experiment, for instance, and then go on to sigma 5 a bit about why there's a problem?
Yeah, I forgot all the details about it. I kind of read about it 2 years ago.
Yeah, it's pretty nuanced also.
But it's something very, very, very important to follow up on. So that's why I'm spreading the word right now.
Like in my experiments on the laser interferometer, I had tested something that was very similar to our conventional lifter, quote unquote, which is a gel knotting type of device that was based on T.T. Brown's work with electrogravitics. And we observed time displacements on that device.
And right. So that's the thing is the muon experiments include CERN. I just wanted to say, so since 1952, they've been doing muon G2 experiments, and like the concern has been time-space ripples, right?
Right, and even more so than ripples, like you have these linear or these collinear type of effects that if you actually map them out over the long term, they are in fact nonlinear. But that's okay because we can still map them out. So what we observed is that with a ion transport at an extremely high velocity, we can distort the local T field between an electron emitter and a collector plate. And we do observe a temporal distortion in terms of the photon transition wavelength and its velocity compared to C over that distance. So when we place a lifter in the pathway of our photon beam, which is in this case it's happening at a 465 nanometer wavelength for our deep for our sky blue, they call it sky blue laser source, then we get this displacement where there's a slight modification in the delivery time of photons from point A to point B coming from our photon source from our laser head over path A and path B, or our X and Y axes. So just simply by passing ions between these 2 points, we displace the amount of time that it takes for photons to travel through that same area where ions are traveling tangentially or downwards directly against the gravitational axes, compared to the laser beam, which is traveling orthogonally or linear to the gravitational axes. And now we can actually observe a real-time displacement of how long it takes for those photons to travel from point A to point B.
What does that mean? So first off, okay, like you're saying displacement, but are you saying ripple effects, like that you're affecting other times in this moment? And are you saying that this moment is stretched or shortened, or what is it? What is it, a moment out of time? Like, what is this displacement? What does that mean?
The displacement appears to be redshifted in your eyes. It appears to be slowed down in the transition for the photon path of this laser path between point A and point B off the x-axis, which is where I place this device. When I run it, it slowly distorts over the course of about 2 minutes the photon path, and I can get approximately 25 fringes of displacement on the x-axis. And once I shut the device off, this is the really freaky part. Once I shut the x-axis off, we get this, how do I say? It's almost like a recoil effect, where time flows back in and it overshoots the original starting position. So if we looked at the fringes on the screen and looked at where they were, the fringes will overshoot their original position and then come back to zero after several minutes. But the weird part, the part that really freaks me out, is I run this system for about 1 minute, 60 seconds, and it takes almost 10 minutes for it to actually come back into its original frame of reference. I don't understand why, but I have to imagine that's a localized space-time phenomenon. And I think it has to do with the localized matter surrounding this device.
Can you explain redshift, blue shift a little bit more? Like that's just something that's fascinating as F. And
oh yeah, gladly. So redshift means that your wavelength increases. You have a photon wavelength, meaning that you have some arbitrary electromagnetic wave function traveling through the vacuum, and it has a wavelength that you can measure. Redshift would mean that the wavelength increases, and blue shift would mean that the wavelength decreases.
So is redshift, blue shifting essentially time travel of waves and light?
I wouldn't so much call it, time travel. I would say that it takes longer for the photons to travel through that same region of localized spacetime. But I don't consider it anything phenomenal, because if we just simply pass photons through a glass lens, they take longer to pass through the glass lens than they do through the vacuum of space.
The most common time you'll hear red shifting or blue shifting is when you have an astral body that's moving away from us or towards us. And so when we see light from it, the exact frequency of the light is going to change based off of that motion relative
Also
to us.
in nanophotonics and lasers and spasers, which are like the really cool tiny like nanoscopic lasers that go in random directions and can split light into different photonic spectrums, then you'll use red and blue shifting also, and you'll get a different latency.
Light into different photonic frequencies, so that's light into sound?
So no, it's that light is a different like size, so it's a nanometer par density. So
well, here's the really crazy part, radiation. Right? Because red shifting is equivalent to gravitation.
Can I pitch in something?
Please.
Yeah, according to my theory or my collection of laws, which are theories, like you said, Jeremiah. I'm saying that the cosmological redshift or the gravitational redshift, the photon does not redshift or blue shift at all. What happens if the time dilation of the observer changes? So the observer perceives the photon at a different frequency because his own time dilation, his own time tick just changed because of the altitude he's at or something like that.
Well, that's exactly what redshift and blue shift is, Phil. It's really just a time dilation compared to the local frame of reference from some arbitrary observer's standpoint. That's
exactly.
All redshift
time dilation, aka time travel. So red blue shifting is time travel.
Well, I got a similar question that Bernie's starting to get at here, but are we talking about time dilation? Or are we just talking about how the speed of the photons, and then saying that the speed of a photon is constant, and that's what we base time on? So then if the speed of the photons changes, is that what we're saying is kind of like time dilation, but it's really just photons?
You're exactly right, because the velocity c at any localized space point in time is directly correlated to what we're referring to here as redshift blue shift. So if the photon travels slower through the region, we call that redshifted. If the photon travels faster through that region than the arbitrary outside frame of reference, we call that blue shift. So anytime a photon changes the velocity local to some outside frame of reference, that's what we're talking about. And in this case, we see a very, very clear redshift as a result of electron momentum from accelerated electrons of the ionic current traveling between the emitter wire to the collector plate inside of this lifter cell that's directly correlated with the pathway of the photonic beam at 465 nanometers from my laser interferometer. And we can clearly observe that on the target plate where we actually get a distortion. And the weird thing, like I said, the weird thing is that it doesn't instantly reflux back to its starting point. It takes a period of time before it comes back into its original position. And that almost seems to me, at least, to indicate that there's a correlation with the wavelength shifting directly associated with matter that's local. So I'm assuming that my lab bench, my shelving unit, and everything else that's around that thing is probably, in terms of the nuclear magnetic moment, shifting its position and accumulating localized energy. And we could probably go back to many, many references. Otis P. Carr would be one that comes to mind, where we talk about the accumulation of energy, or the accumulation of a localized space-time refractive index modification that's observable.
Yeah, so to add on top of that, I explain everything in my book. I'll show later, but the speed of the photon, speeds up proportional to the gravitational acceleration, which is an order of 2. R2, R to the 2.
Yeah.
And the time dilation of the observer changes to proportional to the R1. So it's not the same factor. So but it makes all the difference, because when the observer changes to R1 and the photon changes to R2, then he's going to see a frequency change. But
right, your Compton frequency and your electron precessional resonance completely modifies itself.
Yeah, so I have all the mathematics. I can't.
But also, you might cause issues, because if you're not in a complete vacuum or completely
the
separated.
Vacuum is a misnomer, Andreas. It's not. We're not referring to the actual vacuum. It's not a hard vacuum. What we're referring to is basically the space between atoms.
I mean, even if you just are talking about an energy field that is not fully separated and polarized, then you could have some tensation from the other R1 from R2 and vice versa, which might be kind of the nuclear issue, as something spinning at different states. You could probably find that would be the real problem. If you're not entirely in one or entirely in the other, then both of them might confuse themselves.
Right, they're a dynamic position, and it's not quantized at all. So this is where I have a problem with this quantum inertia problem.
That would make more sense than just radiation causing cancer to me, actually.
I'm not a big advocate of the quantized model of the universe. I don't really see that there is a concrete, discrete unit of energy that is defined as the position and energy vector momentum of every single charged particle. But what I do see is that there is a very definite modification of the refractive index, which is almost like you're not looking at the particle itself, you're looking at the background field. And this is what seems to be modified.
Phil, you were mentioning something a little bit earlier, and I'm curious about this because I'm a little bit ignorant. How much of CERN is declassified versus secret? Is there and I know that obviously kind of like Vatican Archive, anyone can come and check in. It's yeah, okay. But how much of CERN is truly, accessible to the public versus how much is kind of hidden? Because if they're the ones doing the muon experiments, the ones that can essentially disprove what conventional science has told us, could there be someone there that doesn't have the same incentive to just let the truth out?
Yeah, well, CERN is not a solely U.S. owned, research organization. So I don't think there's top secret information on that, or they can't control. I don't think U.S. can control CERN 100%. Maybe the central banks can, but not the U.S. But I don't think they keep talking about. Recently, they talk about CERN discovered a gateway to hell. If you read the latest news on CERN, they say they found a gateway to hell.
Godard's really not that bad, right? I mean,
yeah, I know it's all disinformation. The reporters are seeking clickbaits and things like that. So
it's just francophobic and anti-Swiss is what it is. I think.
Yeah.
No, but I think there is something to be said about how weird CERN is itself and how weird Switzerland is. I don't know. I mean, let's just entertain the conspiracy theory that Switzerland doesn't really care about the rest of the world's wars because they're above all that for a reason, and they're how many bunkers are there in Switzerland? As many as it takes, right? To keep everybody in a bunker. There's like 1,000 person per bunker rule. If you guys get another 1,000 citizens, you have to build another bunker. And how many friggin' bunkers are, so it seems like Switzerland's preparing for the reset and have been for a long time.
Davos is located in Switzerland, so that's something to keep
maybe it's not America. Maybe it's not. Maybe it's the Livonian Empire of the Confederacy of Switzerland. I don't know.
The central banks, the
gnomes of Zurich. Yeah.
Yeah, I forgot the organization name, but they do a yearly meeting over there in Davos. Anyways, but the gateway to hell is all information. The black hole. CERN cannot create a black hole. It's impossible because I don't believe in space.
Well, maybe not a black hole. What about a wormhole or a portal per se?
A hole of color.
Yeah,
maybe
that's what I want to bring up. I don't believe in space warp, but I believe in time warp. Do
you believe in a multiverse, or do you think it's like there's a timeline?
No, there's no parallel universe and things like that. To the point, for those who are religious here or partly religious, I don't think there's another dimension with heaven and hell and things like that. I think if there's a heaven, it's in the same realm, so we could take a ship and go there if we wanted, which is pretty cool in a way. But I think I don't believe in parallel universes and heaven and hell and all that. So I believe that we have a soul, but when we die, then we just are magnetized to some other galaxy. I don't know, but it's not
like there's an alpha point, and then there's an omega point to time, and we're choosing our way, or navigating towards the symmetry of particles arranging themselves at the omega point. You're saying there's no
so there's time can be dilated or contracted, but it cannot be negated. We can't the Back to the Future thing of going back in past. We can't do that. That's science fiction, but we can easily go into the future.
But wouldn't blue shifting be going back into the past, and red shifting, like hotter is faster and forward, and colder is slower and backwards,
or something on that wave talking about entanglement. Because if you're starting with something that ends up meeting like two rivers that meet back at the same source, following the path of least resistance, then maybe there's a way that you could have simultaneous multiple carnations of perspective that meet each other later.
Yeah. But going affecting time negatively can happen, but you can't change the whole planet timeline and go back in the past. You know what I mean? But going in the future is very easy. The cryonics is very easy to achieve because it's some sort of time travel into the future. Is the same thing. Cryonics, levitation, manipulating gravity with gravitoelectric and gravito-magnetic charges.
Am I allowed to do a femtoscale scan of this solar system, or at least planet, and then destroy everything and reprint it with a femtoscale printer, starting from what our AI systems figured out is the way the atoms were all arranged in 1800s or something like that. So basically, it would start over from the 1800s because everything is arranged. All
like
the
the
atoms
universe of Theseus.
Yeah, which is isn't it? Can't we just do the universe of Theseus? Thank you, Simon. I like that.
You can 3D print the solar system at that time.
Yeah, right.
Yeah,
And that'd be kind of like time traveling because it would be the same dimension, same reality, and same material, same mass, just rearranged the way we want.
Yeah, you could do that, but you could also capture the century ago the light emitted by our solar system far away in different galaxy and do a 3D printing of that
Xerox, Xerox in the outback space. Yeah, a couple copies of this. Yeah.
Phil, what you got hooked up here with the second camera?
Yeah, cool. So let me show it to you, man. Hopefully you're gonna hear me well again. I'm gonna speak loud here. Okay, so that's my experiment setup. The magnetohydrodynamics liquid gallium vortex. So I've got everything set up. I've got the power supply, the multimeter, the gallium vortex right here. I can't get too close because there's a neodymium magnet underneath here. So there's a strong magnetic field. I've got my welder to heat up the gallium when it's not liquid. So yeah, that's my experiment.
Epic.
And yeah, you can turn that off right here. Leave there you
go. All right. To clarify a bit on what Phil is showing you there, I mean, what he's got basically set up there is he's using a very high power AC transformer rectified in order to produce a gravitomagnetic phenomena by using liquid gallium rotating in its ionic condition of being self-ionized under the strong electric field passing through a B flux that he's produced under controlled conditions. If I would love for you to elaborate on exactly what that experiment is showing.
Yeah, so last time, 2 weeks ago, me and an expert, we tried to make the gallium spin, but I know it's possible to make the gallium spin because I saw videos on YouTube.
Yeah, I've done it personally myself. I mean, it's very easy to make it spin.
Yeah, that's cool. Maybe you can help me out then because
I'd be glad to.
Yeah, because we're messing around with the current and the voltage, but we don't want to put both the current and the voltage high because there's going to be too much power. So last time we spiked the voltage, but next time we're going to spike the current. So I think it's going to work with the high current, like 16 ampere, something like that.
I do expect that once you get your gallium, the physical mass of all of your fluid rotating, you're going to see that gravitational B field, just like Gravity Probe B from NASA observed when it was orbiting the Earth. And I do think that you're going to see the same kind of phenomena of this frame dragging phenomena.
Exactly, the lens steering or the gravitomagnetic force, the gravitomagnetic charges. It's on a balance, I'm not sure if you were able to see, but it's on a scientific balance. So I should see a shift in weight of 20 grams. That's what I predict.
Wow. You calculated it out. That's pretty good.
Yeah, it's all in my book. It's all calculated in my book. And I want to say also that I'm going to share a screen here. Present share screen.
yeah, your fourth dimensional gravitational B field is going to be super important. And I do think that you're going to see those same phenomena. I think you'll be able to observe them quite clearly.
Yeah. So so that's my book here. That's an event I'm gonna go at in Honolulu, Hawaii in August. By the way, look at that. My company is here. I'm gonna be right next to Lockheed Martin.
Sweet.
That's pretty crazy, man. So they're probably gonna. I don't know. It's a militarized hotel, so I don't know what they're gonna do to me. If you don't hear back from me, then you know what happens to me.
We'll probably for details.
Drop me off. I will be part of the rescue party, and just drop me off somewhere in Hawaii.
Yeah, cool, awesome. I count on you, man. So
Hopefully
yeah,
they just offer you a job.
I don't know,
Or not, because then we won't ever see Phil again.
I might. Skunkworks isn't too far from San
Yeah,
Diego.
more likely he'll get
Not
a gig order. And
We speak in Quebecois, and the AI
gig
won't know what
order.
we're saying. So.
A gig or a gig order. I like that.
Yeah, I wouldn't mind having a job with Lockheed Martin in El Segundo, California. That would be pretty cool. But I know all the defense company are there, so you know. But I don't have U.S. citizenship, so I'm not sure what they're gonna do. So let's see. But
Marry you off to a trans soldier.
yeah. I identify as a U.S. citizen.
There you go.
Maybe that's gonna work.
Do we have the Starship Trooper doing my part meme queued up?
There we go.
So yeah, I want to share that Dr. Eugene Poklenov. I'm having trouble pronouncing his name.
Yeah,
Sorry
you
about
got
that. But he from Jeremy Reese. Who made that video 12 years ago, Dr. Potlegnov, he already measured spinning disks of 30,000 RPM that will create a shift of from 2% to 9% of gravitational weight. So I'm going to play the video right now.
A special installation which allowed us to use much higher speeds. And every object that is put over the disk loses some part of its weight. In the stationary...
Yeah, on top of the disk, that's because it creates gravitomagnetic particles. Gravitomagnetic particles are chronons. Chronons will shift the time, will time dilate or time contract the acceleration, because acceleration is meters per second squared. If you change the time of meters per second squared, then you're gonna change the time of the gravitational acceleration. So in my book, I calculate everything. I didn't see the video before. I just saw it last week, and he's getting numbers exactly the same order of magnitude that I predict in my book. Which is awesome.
The loss is not big, it's about point.
That is awesome.
1%. But when we rotate the disk and use resonance frequencies of the electromagnetic field, we can increase the weight loss up to 2%. And if we increase also the rotation speed, we can reach the maximum values of 5% and at some peak values up to 9%.
So just to give people an idea, stop sharing. Just to give people an idea, like if you have gallium I have 1,500 grams of great gallium. 2% is like 20 grams, something like that. So
is gallium the metal that dissolves and like eats up other metals, like it's kind of liquidy and turns into like alloy, or is that something else?
Yeah, the there's corrosion with gallium and lead, so I had to put a tungsten layer or coating on my metal ring, so that gallium is not gonna corrode with the ring metal. So yeah, otherwise I would have some sort of some mixture right now.
Amalgamate, I guess it's called, right?
Yeah. To answer your question, Bernie, gallium does tend to erode or actually combine with and amalgamate with most metals. So gallium is a particularly what do we call that?
Corrosive,
caustic chemical.
Yeah.
And it will combine with almost every single metalloid that we have in our current repertoire.
Destroys aluminum.
What about mercury?
Mercury is extremely toxic if you touch it, but it's more massive. So slightly more. The volume mass density is slightly greater than gallium, but it's toxic if you touch it. Then it's gonna get in your blood, or I don't know. It's gonna. I don't want to know what's gonna happen, but it's toxic.
Well, let me correct that, because mercury is only toxic to humans as a salt. So raw mercury is actually not toxic. It can't enter the blood.
When oxidized.
And
but you're also full of salts, so you don't want it to bind with anything.
Yeah, it's around $1,000 or $900 US for 2 kilogram of gallium. So if you have a cheaper price with mercury, then go for it. I can share my source of gallium easily. So I think Space Case is showing some mercury right now.
Yes, I was.
Is that mercury?
Yep, it's mercury.
So how much did it cost?
I was at a party and somebody said their father had it and they didn't know how to get rid of it, and I told them I wanted it, so they brought it to me.
Okay, that's pretty
Whoa,
cool.
so you just got given a giant vial of mercury for free?
Well, he's not the only one. I mean, I managed to acquire, and
I want that.
Y'all didn't hear it here, but 22 pounds of this stuff.
I want some.
Okay.
Me too. And of course, Jeremiah has that.
Based.
Yeah. So this weekend or next week, the expert is gonna come back here and help me out with the electric circuit, because I've got I needed the resistance. The problem with gallium is when it's solid, the resistance is very low. When it gets liquid, the resistance increases up to 50 ohms, and it changes everything. It changes the current, and when it's gonna spin, the resistance is very dynamic. So I needed a resistor. I need to put the resistor in parallel to stabilize the resistance of the current. So it's kind of out of my field. So that's why I'm kind of relying on an expert to help me out. I got all the equipment, but I just need an expert to not to blow up anything or blow up a fuse or anything like that. So
I'd be glad to help you with the application. I can't help you with the equations because that's not my expertise. By the way, Gerald, super glad to see that you're here. That's awesome. Gallium is a really good substitute for mercury, but it's still not going to give you that ionized ability that mercury naturally possesses.
Where do you live, Jeremiah?
Wisconsin.
Oh, that's very close to Montreal.
Yeah, actually, we're just below the Canadian border. And I do intend to visit you guys out there in the great CA Maple Leaf.
Maple Leaf, yeah. Forget the Maple Leaf and forget the Canadians. They're not gonna win any Stanley Cup anytime soon. But all the winning teams in US are made of are made up of 80% of Canadian players. So it's the same thing, you know.
Oh yeah, we definitely don't recognize here in our United States the value of our local neighbor Canada.
Yeah, but that's all right. Doesn't matter. I'm gonna move to San Diego pretty soon. Hopefully this year, but we'll see.
Behold, the only man moving to California.
Yeah, I've been there before, and all my friends have been asking me for like the last 12 years when I'm gonna move back. So I just want to. The thing with US is the visa system is a little bit complicated, but now I'm gonna re-enter the US as an entrepreneur. So I need to get the right visa for that. So, but once I've been there before, but now I went back to Canada, but now I'm gonna go back for good to San Diego. It's a very freaking awesome place, man. I love that place. Coronado Island and all that stuff. It's really awesome. Pacific Beach, that's where I used to live. But yeah, I'll pay you a plane ticket, Jeremiah. I don't mind at all to pay you a plane ticket if you want to come.
If you go down to San Diego, I'll meet you. I'm up in the Bay Area.
Oh, nice. The Bay
Area.
Area.
I'd like to help you with your gravitomagnetic research, and I think that you're right on the ball as far as the direction of your research efforts, and I do believe that with what you're already doing, we can probably find the solution.
Yeah, I just need like a safety box, like a safety plexiglass box to put, because it's gonna go at 20 or 30,000 RPM at some point. So if I screw something up, I don't want the gallium to be all over my apartment. So
Yes.
I'm gonna have to get one of those plexiglass box.
Is there a high-speed gallium clause in your lease agreement?
Yeah,
I don't think that's legal in the tenant clause.
Yeah, I asked if I could do my experiment outside on the patio. They didn't answer, so.
And gallium being highly corrosive, but
to metal, to other metal, not to skin.
I know that. Yeah, exactly. It gets the iron or of basically just steel or aluminum, tin, I guess, sidings and stuff. But you're trying to go for weight loss, so obviously you want the lightest materials, and that's why you're choosing gallium over mercury. But for extra effects and reactions, I'm like in my mind just seeing that if the gallium and mercury are able to amalgamate into one kind of super fluid, that you might get more transmutations or different superconductive properties, or easier into plasmid plasma sort of self-organization reaction structures. What's the word? They call it the lattice sort of geometries forming within, and that the red mercury could be a 50-50 mix of it. There's lots of tales of them also dissolving some gold or silver into those mercuries and gallium, and then rotating them at extreme high RPMs counterclockwise.
I did not know that. I did not think about mixing mercury and gallium together, but I know there's gallistan, which is a gallium alloy that melts at lower temperature. But I don't know if it's better than what you're suggesting.
Each different experiments to try one after the other, see if it makes any difference, and you never know when you'll just get this random odd breakthrough on something, right? And not 90% of the time, you know, it's going to turn out as you suspect or do nothing, but it's the one time that everything disappears or something appears out of nowhere that it's all worth it.
Well, a lot of the times major breakthroughs aren't eureka, it's that's weird. You know, like, oh, the test result should be this and it's like 2% off. Why is that? And then it ends up being important for some reason.
Right.
Yeah, it's like, I don't understand why. But to go back to the frame dragging or the lens tearing effect or the gravitomagnetic field, it was kind of dismissed for so long, and the theory is based on an analogy. It's not derived. But in my book, I derived the exact value of the gravitomagnetic permeability. I derive it. It's based on, you know, it's not an experiment. It's a mathematical derivation. It's very simple. It's algebra. So that's why I know I'm right, and I got the exact same prediction as what Dr. Potleknov was predicting. I got the exact same values. So everything works. By the way, I did try the elf waves thing, but that was a trap. I fell into a mainstream trap. Do not try this at home. Not because it's unsafe, but because it's not gonna work. So I've got I've got an antenna with a low wave pulse generator that I'm gonna resell and or give away. I don't even care to my friends here in Montreal because it's cool. It took me some while to get, but it just doesn't work. But that was a trap. Elf waves, forget about that. Elf waves is just low frequency electromagnetic waves, but we had to make the distinction that the problem is that the graviton is kind of in the mainstream schema. The graviton is kind of similar to the photon, but it has spin 2 property. But the graviton it's not like a photon. It should be compared to an electric charge or something like that. Like the chronon is a magnetic charge. Should be compared to a magnetic
spin.
Sorry?
Isn't it like electro plus magnetic fields plus spin?
Yeah. So, well, the spin, half spin and spin 1, it's like a physical spin, but spin 2, it's kind of a mathematical tensor.
It's the implosion in, right? It's going from the macro to micro, from physical to like fractal.
Yeah, some sort of abstraction, mathematical abstract, the spin 2. So I'm just saying that the graviton should be compared to an electric charge. The chronon should be compared to a magnetic charge. And the graviton should not be compared to a photon. So that's a distinction that took me some time to figure out, but it's very important to be aware of because it's easy to fall into that trap. So that's all. That's pretty much all I have to say. Again, Jeremiah, I'll pay you a plane ticket, man. That would be pretty cool to spend I got a day job, but it would be pretty cool to spend a week to work on that together.
Yeah, I really think so. I mean, as far as mercury and gallium, you have 2 variable ionizable liquids. and they are extremely viable for MHD acceleration. So both of those things are highly conductive fluids, and it's not too difficult to give them some arbitrary angular velocity. And with both those things, you're going to end up with the internal stress energy momentum tensor inside of those fluids. And they're going to produce a localized change in the refractive index of your space-time within the fluids themselves. So gallium is okay, but it's only okay. Mercury is almost a 5-fold gain when it comes down to a comparison against gallium for your local refractive index change due to its incredible and remarkable ionizability. And that has to do with its atomic properties and the valence shell distribution of its instabilities. So I know that most people don't want to work with mercury. They look at mercury and they say, well, this is something that's really dangerous and it's going to kill us all. Fuck that. Mercury is a fantastic option, and it will give you the results that you're looking for. So don't be afraid of it.
What I will say about mercury and the safety profile is that can you imagine someone driving a car where it was filled with mercury?
I absolutely can, and I don't have any problem with that at all.
I don't know. I've seen drivers. I don't trust their competence to not crush that.
Well, Teslas, don't they explode like 13 times or 18 times? Something just crazy like that?
Well, I mean, they'll keep burning until they're out of energy. That's the thing with batteries. You can't just put it out.
Mercury's a lot more forgiving than you might expect. I mean, you have to be within the vaporization temperature and pressure threshold to have any kind of personal risk. Otherwise, mercury is going to remain in its liqueous state.
Yeah, but I don't want it to like get into the groundwater or something either.
I agree with that completely.
This coming from the guy who like nuked his eyeballs the other day. I'm just saying.
Well, and they found
mercury. Andreas is right. He called me. I did burn my eyes pretty badly the other day with some.
No, with mercury, but it's just the principle of safety. It's like, well, what do you find safe?
Plasma mercury.
Don't do this at home.
Well, also,
your idea of safety.
How much did Jack Parsons would buy to those?
You remind me of the ladies that keep taking pictures of their like pregnant tummies like pushed up against the nuclear reactors. You know, they're like that's some good.
No, just the yellow sand or whatever it's called, the uranium that he likes playing with in between the glowing rays of burning whatever.
Do you want to give birth to Superman or not?
Or you have the radium girls,
I don't understand you guys. Come on. What's wrong with eating a sandwich while your hands are glowing?
Honestly, it's easier to do in the dark.
Oh, man, he called it.
Nothing.
I don't mind being able to see in the dark.
For months.
Hey, I've got a random question for you guys because I'm just curious if there's any practical application of aerogel in any of your experiments, or if that's just something for like NASA installation only.
Aerogel is useful for everything. I mean,
like, have you guys ever found any practical
agree more,
uses?
Andreas. Absolutely, aerogel is useful for everything.
Yeah,
everything across the board. Whether we want to capture a very large thermal differential within a confined region using aerogel and heat it up, or whether we want to simply catalyze these strange configurations of carbon. Aerogel
create like a micro pressured vacuum in small parts of materials, or if you want to use it for, I mean, even just having it for like induction composite materials as well. I mean, it just as a lattice, using aerogel as a lattice for growing crystals.
What is this magic stuff you speak of? It sounds like everything I need to deal with my self.
It's just not quite a gas. You know what I mean?
Always wondered, would aerogel be like a good electrolyte for a form of a battery? Maybe, I don't know.
So aerogel can be used as kind of as a lattice structure for all sorts of things.
You need to pull up aerogel, so
including heavy.
Apparently, not everybody knows what it is. You've got to pull that up.
They're weird to look at. Like touching them.
Okay.
It's a hyper ultralight material, but you've dealt with aerogels kind of, if you've ever, like a dandelion is well on its way to an aerogel, you know, in the way it's designed and the way it fills up so much volume of space while still having structure. And there are amazing aerogels which can hold up pieces of steel essentially that look like about the same material or almost invisible at this point because of graphene, or even salts. They have salt based aerogels as well, which can shatter and then they can recombine. I mean, there's a lot of different uses for them because some of them are super light, and I mean they're all super light but super weak and can super degradable, and so that you can use them in a way that you can remove later. Some of them are super strong and will never break, and you can put this in between materials, use it for insulation
depending on the lattice crystallization structure of it.
And yeah, you can also grow crystals in it. So that's the other thing, because a lot of the time it's like a liquid crystal polymer, or again, a carbon structure or a carbon net with hydrophobic dense pores. So the top of it will often be so small, the material netting, that it looks like egg crates, and the water droplets would fall in between the egg crates because it's so small. The water droplets are bigger than the tops of any of the points, so water would roll off this material, so it can't get wet, can't absorb water. I mean, there's a lot of different kinds of aerogels, and graphene-based aerogels are becoming more and more prevalent. You can see I mean, I don't know if what your question exactly was, Thomas.
I love the idea that you said that you could use it as a lattice for like crystal formation, which would be like a really cool practical application.
Yeah, one thing I'd say is the best thing is if you were to
lattice, the low energy nuclear reaction geometric crystallization lattice of these nano superconducting layers. That's what this is to the maximum. And then is this stuff 3D printed, or
imagine
this is essentially quantum material?
You can grow this material bottom up.
I think I'm growing some of it in the jars.
There's a number of different ways to do it, but a lot of times you can use electrolysis with like an ammonium sulfate solution, add graphene or carbon.
Isn't it sort of like freeze dried in a lot of methods?
So you can use hyperchemical deprivation as well, so CVD and sputtering and heat, extreme electrolysis is a big part of it. But once you make when you make your aerogel, there's so many things like after that you can decide so you can choose what material you're going to use in the same process, and that changes everything about it. And so they're thinking like, what are you going to do with material sciences? You can use aerogels in the surfboard and make an ultralight surfboard that's better than a balsa-wood board because you have a certain amount of pressure from the air, and then it's filled at that point from the vacuum with this aerogel, which then expands, and you have a super strong, super light material, which then can hold air in pockets the way foam can. So you can have an ultralight Zeppelin, which the aerogel is just about as light as air, and then it'll hold the air better than a singular balloon would, which could pop at any point and lose air because it gets stuck inside of the foam.
Yeah, it gets distributed throughout the entire
and if
thing.
The material is translucent and it's coated with ammonium or ammonium nitrate, and I forget there's another chemical that helps with this, but it'll cause heat, right? Because of the chemical reaction from the heat. So you could create a flying Zeppelin that was self-powered, that lift came from the light actually shining through and heating and activating the ammonia. And then you could maybe, like the way your sunglasses work, have a tint on it that the darker UVs aren't allowed through, and it keeps it at a certain height level. And that could be controlled by graphene as well, like the different lines allowing for
you could use like electroactive polymers to like lift up flaps that expose more light or something. You can get weird.
Right. One of the things I think would be really cool to use an aerogel for is 3D printed chips, right? So once you start layering your graphene chips that you're printing, because then you're no longer shaving and 3D printing in 7 layers. Now you'd be just layer after layer at an atomics level. So you could have like a city of chips that are all stacked in the aerogel, and then they're interconnected through spacers. So that'll also make computers far more powerful, and it would essentially they'd be wireless, so they'd just be stacked on top of each other and bungeed together inside of the aerogel.
What are we looking at here?
This is outside the window of the Apollo 11 shuttle.
No, they're at like Apollo like 500 and something by now.
Jeremiah, you are
Jeremiah's
muted if you're
playing
speaking.
again.
They're doing goddesses now.
This is some essentially oh my goodness, the Sapphire project, right?
That is a beautiful color, though.
Isn't that Jeremiah's vacuum setup?
Yeah, that's exactly the.
I wonder what the gas is in there.
It's cow farts.
Jeremiah, you're muted. We can't hear you at all.
Mic
Just
drop.
realized.
Yeah, my apologies. Like, I don't want to. It's gonna echo, so my apologies.
Vega experiments, right? The Vega tubes pressurized from Martin Fleischmann Memorial Project, Bob Greenier's stuff, and then the Sapphire Project, similar stuff, right? This
It was actually really interesting as it was shutting off there. You could.
Oh yeah! Wow. So those sparks, those arcs of different light coming off, that's probably transmutation of elements happening within there, right?
Look at all the colors coming off on the point there.
Red blue shift makes you wonder.
It would definitely be the EVO factors.
He needs a spectrometer so we can see what the elements are get in there.
Yeah, those are very pricey though.
Oh god, we got to figure out how to do it in the smartphone app things. There we go. How did someone use Chat GPT-4 to build a smartphone mass spectrometer app that everybody can use? That would revolutionize this community and world in a heartbeat.
Talking about ChatGPT, I tried to access Bard, Google Bard.
Sorry, not just ChatGPT. What's Orca? Like Orca is supposed to be like the next level or something, or the competing one. Can anyone go into that or explain that a bit?
Isn't it Bard, Google Bard?
Orca is the Microsoft one. So it's not that different. It's kind of like a hybridization. Like, so Microsoft worked with OpenAI. OpenAI created ChatGPT, but Microsoft was involved with that. This is Microsoft's kind of spin on OpenAI's ChatGPT-4. I mean, it's basically ChatGPT-4. It's just its own like fork. I would say it's a fork. It has different things going for it, and I'm sure it'll be more practical in some ways, but I mean, so the thing is, ChatGPT-4 is really broad, and a lot of what's going on in AI right now is narrow AI. So they're trying to figure out, same with education, right? Try to make people aware of narrowly aware of certain subjects very deeply, rather than shallow awareness of broad amounts of subjects. And so ChatGPT-4 is aware of a lot of different things, but it's not really deeply aware of them. So it's like aware, if you're like, hey, write me a recipe. It can pretend to write a recipe because it knows what recipes look like, but it doesn't really understand them. And the same thing with like law. It'll create fake court cases, etc. You can make a narrow AI that's really aware of recipes and really aware of the intricacies of how things work together, how laws, which laws actually exist, which case laws are true. That's where Orca is going to excel, is that it'll have better webhooks, better access to the internet, but it'll probably be less personable.
Jeremiah, was your equipment smoking?
Dude, kids and machines
He
need to stop
couldn't
smoking.
see because his retina's burnt out.
Every machine is a smoke machine if you push it too hard.
That's the answer right there, boys.
Could be ozoning though, or arcing different transmutations that off the EVO sections.
Hey, Jeremiah, send me your email address or somebody who has his email address. Please send it to me. Thanks.
Exotic propulsion. Just hit me up. It's all one word.
Well, is there anything else you guys want to?
Chat,
what
Phil.
else are we trying to make sure we cover? We got about 19 minutes left. What do you guys think?
Yeah, that's a shame. Actually, we were getting the plasmatic fusion at the end of the copper electrode, but unfortunately, I am having my transformer smoking right now. So it appears that my vacuum was not sufficient.
You're not supposed to let the magic smoke out of the machine, then it won't work.
It tends to come out every single time I run this experiment. Well, then again, like I said, this is only a 700-watt transformer, and it needs to be a 1400 watt. Now, there we go. Now we have something truly miraculous on screen, and that is Adam's Bagel Coil.
The triple toroid bag of
something about
coils.
these things. So this one's got what people will call a left-hand spin. So as you go away from you, it goes counterclockwise. And
That's
something
how
I found
I
out
do
playing with
mine.
this thing. So I figured out with my little handheld high voltage power supply here, I can hold it from either side and change the polarity on it. And I found out the fields created by the left-hand spin are electrically negative. And I can push them around and move them like that. So if I'm holding the positive end, it'll zap right to me, and I'm the sensor, and it hurts very bad. It's maybe not a great experiment, but it definitely showed me these things are negative electric charge. So I'm going to make a right-hand spin one and see if it acts like a positron. But I'm pretty sure it's going to, because this acts completely negatively, and I'm running alternating current into it. And I think this gives us some really good insight as to how an electron might actually be made as far as the internal format. Anyway, just wanted to share that with everyone.
Zapping yourself is not the ideal way of testing whether it's on, though.
Yeah, that's definitely the way to test if your heart is still on in the morning or immediately thereafter.
I know there are better sensors, but they're harder to build, and I already exist, so.
It doesn't get greener than that, right? That's the organic way is the green way.
Right, so blue shit, what is like RGB, like red, blue, green, but we're taught primary colors are red, blue, yellow, and you have the red, blue shift, red, hot and faster, future, blue, slower, death, like, well, what is all of this stuff? How does it, what is the green then? Like,
that is rough. I better open a window. I mean, this stinks like
why not
CYM pretty bad.
Oh, once again, proper safety in the lab of well-ventilated air and.
So
God,
once again, please don't do this at home, people listening to this. I know he's doing it at his home.
Woo! I'll tell you, man, that is definitely a stench that you do not want to continuously breathe in. I mean, like I said, it smells like a small scale train set, except for we have very clearly burning sensations of the enamel, and the fact that it's smoking, I think, says it all. And that's the 700 watt limitation. It needs 1400 watts. That's the minimum limitation for this type of transmutation phenomena. And that glow that we've seen, even though, of course, the video is short and it didn't last very long until my transformer almost caught fire, we see this very bright luminous event at the end of the copper electrode. And when it goes from basically our normal copper phosphorescent type of output from green to white, and we get a very widespread spectrum, The spread spectrum, in terms of the spectroscopy of individual metalloid elements, is an indicator of what is coming out of that system. So when we get the wavelength shift from one color to another, what we're looking at there is a real-time transmutation of physical elements from copper into other heavier metals. And they are happening via a fusion event at the tip of the electrode from the copper wire, which is a 14 gauge solid electrode, into other heavier elements. And that's exactly why we get that transmutation shift. That's exactly why we get the other wavelengths. We can see them on the spectrum, and there's only one way to generate those types of spectrum, and that's through transmutation. You have to have these other elements. So basically what we just did there in our tiny little 30-second lasting experiment before the transformer started to smoke is a real-time proof, live streamed, of physical transmutation, real alchemy of electromotive force, converting the nucleus of elements by bombarding physical protons, neutrons, and by ripping off the electron valence shell into other elements. I think that's kind of cool. I mean, personally.
Yeah, that's amazing. As I was just saying, actually, because I know I'm leaving early. It sounds like the show's going to keep going for another 2 hours, which is awesome. But it's all been great real science stuff, great experiments, great theories, great proofs. Like, this is all coming together pretty good.
And ending it with actual live transmutational alchemy. And so everything that Jeremiah just stated is exactly what I've been getting on my electrodes, on my anodes especially, but also the cathodes in this electrolysis jars, and what the Iranian Keshi calls the cup of life. But that the only difference is I'm just doing it in water with very small voltages. And when you combine the two of getting that arc of the ionized plasma, ionized gas, whatever the heck it is, the glowing, gooey, ball lightning material, orbish stuff, that if you have that in water, then you now have the density and the mass and elements to be working with the pure metals and salts, crystals, and transmutations of no longer just the gases, but crystals and metal elements and so forth, and full-on fusion.
Yeah, it's really not that complicated. People think that this is an impossible feat, that you cannot transmute elements, but it turns out to be a rather simple endeavor. And all you need to do is strip the electron valence shells off and smash the nuclei against each other, and it turns out that they will combine. And there's no surprise there. I mean, if you have a bunch of protons and neutrons and they don't have an electron valence shell to block their communication, and you slam them together at a very high velocity, accelerated through electric polarized field, then you're going to get some kind of combination there. So it's not an impossible feat. I don't know why it's such a big dogma in the scientific community.
Well, I mean, only stars can make elements out of other elements, Jeremiah. I mean,
of course.
Humans could not do it. Obviously.
Right.
Yeah. How could we ever step outside of the boundaries for cosmology and think that us humans, us pitiful monkeys, could ever do something fantastic?
You guys keep
that's right. Electricity doesn't
better.
care about our emotions.
Do you know the history behind why they thought fusion can't happen?
All right, Xirtus, you taking off, brother? I'll end it on your channel, and if you'd like, or would you like to keep going? You're muted.
Yeah, I'm gonna have to check on my dad, man, but I want to come back because this is pretty great. So I'll be trying to pop in and listen and stuff. So if I get some more time, I'll pop back in.
All right.
So would you like to continue on your channel or end it on your channel?
You can keep it going. Yeah, just keep it going, man.
Oh man, that transformer stinks
All right,
so bad.
I'll be back.
Sounds good, bud. All right, before we lose Thomas, I'd like to quickly bring up some ancient alchemy symbols and see if you're still there, PA.
Yeah, I'm here for at least another half hour.
Perfect. And get some AI going with that. and that I personally suspect there's like physics and like the form of like matter solidification of like crystallization and this cold fusion alchemical process that I've been talking about through electrolysis, everything that Jeremiah just showed in the. So what was that experiment called, Jeremiah?
So what we're looking at here is a modification of the Vega experiment.
Yeah, it's
by
the Vega.
Greener.
Okay. Yeah, so that's the Vega, and then it's that's essentially the same principle and like experiments department as the Sapphire project, the Electric Universe group too, right?
Yeah, it's directly related to the Sapphire project work.
Beautiful. See, and then I see you want to do it underwater, but while you have the monoatomic metal elements of like gold or silver or whatever the heck you want, or maybe copper, and you can just turn that copper, add in a couple of these atomic hydrogen molecules that you're making from water that just happens off the cathode sides. That's a very basic of electrolysis. Alchemy, of turning water into hydrogen and oxygen. And then if you can just bump a couple atomic hydrogens off of this or on into that electrode that you have in this red lion, is what the ancient alchemists would call it, state. And that is this crystalline pink red active, what we're now understanding is a metamaterial lattice structure. When alien scientists did an episode on it, Jeremiah, you were there a couple months ago, of this breakthrough red metamaterial lattice structure, and it turns out to be a combination of hydrides, a hydride lattice structure. So it's like, okay, so is that just these atomic hydrogens forming a like layer bonding or in between the metal and the water, like all these different things? But it's fascinating stuff.
No, right, you're not wrong about that. I mean, the hydrogen is our most basic element universally. So we can convert hydrogen to many other things, because basically what we have with hydrogen is a single electron and a single proton, and we can slam those things together and create brand new elements straight out of whatever we have for our working materials. So we can convert hydrogen to many other things, and the sun already does this. Any star does this naturally. It's not a complicated process. It's just thought currently in our paradigm of science that it's something we cannot control as human beings. But it turns out that we can control it, and that we can produce these types of phenomena very simply with high current and high voltage by slamming nuclei against each other, and they will combine.
And a key part is this aerogel stuff that is your material that you're going to form. I see this as like the monoatomic material that I make and have, and that it's in a nano lattice cell structure of, for instance, your shaving gel. You have it as this liquid, you puff it out, and then it's aerates, foam, but solidifies into that crystalline lattice structure. And that if you're getting it in these specific sacred geometrics, the Platonic solids, but these hexagonal, pyramidal, crystalline superstructures, and that if you're able to have the direction of the current, all of those different nano particles flowing or aimed in one specific direction all at once at the moment that gel hits the air and expands and solidifies, freezes, and hit it at the same time with those resonant frequencies of the elements, and you've got some next level Star Trek 3D printing, essentially.
Well, now you know why I want your physical gel-like aluminum structures that you've been able to produce in some of your various experiments. You do have, this gelatinous type of aluminum mixture.
Oh,
and I
yeah.
would really like to know what the heck it is. I would love to put it under SEM and figure out what it was, what the hell it was that you produced.
And how many different red lion reactive different metal elements and nanomaterials that I've also created, and these translucent pure metal element gels, and also what Keshi says are the amino acids and the oils that form on top when I drop my blood in, and then it starts foaming up top. That's essentially an aerogel that I've actually gotten several samples of collected before, right as it crystallizes and forms. And I suspect if it's coming off of your aluminum, zinc, copper anodes, that would be what that gel foam would be made of.
Well, I've looked at the samples that you have, and I mean, there is a strange phenomena going on whatever the heck you have. I've looked at slime molds and various other things to try and figure out what is growing on your electrodes, but you have this gelatinous type of semi-translucent, almost almost clear, semi-opaque material that comes off of an aluminum metal structure. And I do not know what it is, but I would really like to figure out what the heck it is. How does aluminum turn into a gelatinous structure under these high salt conditions? And here's the point that I want to just throw out there for the audience. Salt is extremely toxic for almost every microorganism and other types of mold. So it's very, very, very unlikely that we have a mold forming in this type of gelatinous structure on these electrodes. So what the heck is forming on your electrodes that physically shapes itself, holding its own structure that continues to grow over the course of several months off of your individual conductors?
Yeah, and it literally freezes the biological decay. It preserves the cellular bio matter, and actually, for instance, mucus or blood that I've put in while it's still alive, it will actually exponentially grow it like never before, and it literally turns into this jelly cellular blank freaking what the hell nanostructured thing material grows, and then the blood, it will actually turn into these plasmid clusters, and then grow into other things as well. It's
I hate to mention Keshi, but they did even the Kesh Foundation talk about this kind of stuff and speculated on these topics. So
that's where I learned it all
from.
from.
They did indeed talk about these things as a possible outcome for the types of events that we're looking at here. And so there must be something there that we need to understand, and they did not provide the technical details, so I guess that's up to us as the engineers.
This aerogel stuff, if I'm making it, say it's made out of, it turns out to be monoatomic copper if I'm just making it off of the pure copper anodes, or if it's off of the silver you'd be having and get it and can preserve that while it's in the foam state. If out of silver, you'd have it as the silver aerogel, and that it forms when you put your blood in immediately. White, just this white material just comes up with the each atom of the atomic hydrogen and starts building and going up with the atomic silver. So what Keshi's also major part says is that it's forming your nanocellular structure that is like your single just resonant frequency mass cell, I guess, or whatever building.
Yeah, my issue with Keshi is the same one that I have with a lot of scientific endeavors, which is they have this overwhelming scope or sweep of claims, and they don't justify them with any kind of technical data. And that's the major issue, is that they're not replicable. So
yeah,
you
well,
might
a lot of
accidentally
it's a work in progress and theory, and you gotta listen to all the testimonial episodes. They do about 14 to 16 hours of streams a week, but
Yeah,
it's
but
like
testimony doesn't get us
the issue is that out of that, I'd say 80% is metaphysics and like emotion and spiritual stuff, as opposed to actual real science, physics, and medical trial.
Right, and today's episode, Real Science, I mean, we can't deny the possibility of metaphysics maybe being involved in these things, but we can quantify metaphysics, and that's not something that should be outside the genre. My problem with Keshi is that they don't quantify any of the metaphysics that are plain. And so we end up in this very weird kind of gray zone where there are no actionable pieces of intelligence that we can replicate independently. And so even though I do recognize some of the claims as being, well, carried out by yourself and some of the experiments that I've done, I can't actually validate any of those things because the claims are not solid.
Well, it's like I understand the vast majority of it, I'd say about 80% of the theory of it, and then from what I've seen of all of like the private experiments before they went like straight into the non-disclosure areas of the Keshi Foundation from the public population doing and building and testing them, and then showing it to tests publicly, sort of thing. And then as each discovery or technological advance would be made, it would just like get expunged completely, and you'd have to either join into their NDA to get access and develop it more, or just doesn't really, haven't seen it really talked about or developed since, and a lot of the things.
I can agree with that. I mean, I've been lucky. I've never had to sign any kind of NDA. I've been offered many opportunities, everything from Skunkworks to others, and I have never signed an NDA. I've never actually incorporated myself into those programs, and so it was a narrow cut. But luckily, I'm still free to basically talk garbage online because I have no contracts. And that's a wonderful thing. And I would suggest that anybody working in this research category never, ever, ever sign an NDA.
Yeah.
Basically, like you're basically imprisoning yourself when you do that.
A lot of NDAs, you're not even allowed to talk about having signed an NDA. So you have no voice.
I've been offered them a couple of times, and there's no way I'd sign that, because odds are I'm already working on that sort of project anyway.
Oh, Adam, you so are. I mean, you've discovered things that these boys topside would be drooling over.
Yeah, you basically say you don't believe in the project because if you try to work on it on a successful project, then you already rejected it, you know.
Yeah, but not everything that has an NDA is successful, right?
No, most certainly not.
It's just like how they...
For the most part, like if you need to sign an NDA, chances are that they don't already have the answer. If you have figured it out, you do not need to sign an NDA. You need to stay far, far away from any of that type of dogmatic legalese. It's all lawyer talk. It's completely toxic, parasitic, and us researchers, we need to never get pulled into the NDA trap.
I mean, you say, you know, not every black project, for instance, is going to be successful, but like, what is success? Like, that's going to be a very different answer from person to person. And I think researchers, having it mothballed, rotting away in some warehouse, that's not success, in my opinion.
Well, that's why we do live broadcasts of these real-time experiments, even if the transformer happens to smoke and start burning up.
Yeah,
Okay,
but I
red,
think it's
blue
worth calling
shift.
them out. You know, they
What we
are
have up
entirely
here.
too high and mighty about this shit, and they really don't deserve to be.
This is key stuff right here. Walter Russell and his six division of electric current. Red, blue, red, blue, red, blue, red, blue. When I have my coils, they're either triple solenoid Keshi wound style coils of copper anti-clockwise in sections of 9. That I would put into the electrolysis. It would always come out alternating back and forth between blue, red, blue, red, blue, red on the coils. And it's like, why is half of it oxidizing into blue and half of it turning into, is it hydride red or some other compound, but back and forth. And this red-blue shift that you're talking about earlier, and then, you know, this right here, you have the copper and you have the ferrite rod in between, the electric vortex around and the magnet solid through. But Keshi himself, the difference between his Magrav coils that were of a same diameter throughout, the coils, his spaceship reactor coils were these the spiraling small to large in the central to small at the tip again, triple copper coils over and over again in these multiple triple layered, it's just like circles upon circles upon circles of copper solenoids connected within each other. And how is this, where do we get this red blue materialization of color, force, and what is, I just...
And this is where the spectrometer comes into place. Now, of course, you have been offered a possibility of getting a spectrometer. So I guess it's just a matter of you picking one.
And sorry, I'm also just bringing up certain possible references for AI art or graphic generations. The dimensional shapes and proportions of the octaves that Walter Russell used is, I also believe, a very key part. But
well, I do like Russell's diagram of the elements. I think that the snake-like elemental layout is probably one of the most prolific types of elemental constructions that we currently have in our modern science. And I absolutely love the way that it fractally plays itself out in terms of the multi-spectral magnitude of each of these elements. It really does seem to make a lot of sense. I don't know if you have a reference diagram for Walter Russell's type of S-curve elemental layout, but it's a very interesting and fascinating diagram.
It's vortex based and also on the octave harmonic scale simultaneously, which it's the proportion of how it works, just the symmetry of it.
Just to reference it, it'd be great if you could pull it up, because
yeah, I'm looking for it right now.
It's a really, really intellectually fascinating concept to look at the elemental layout of all of our recognized materials, and just to see them laid out in that particular fashion and how they relate to each other. It's quite unique. And yeah, there are 3 other variations that have nothing to do with Russell, which also, I think, concrete the same idea that there's a fractal association with every single element, and that we see these kinds of paradigms continuously executed again and again over the entire scope of both the proton, neutron, and electron ratios. But yeah,
the
there you go.
fractal geometries of it, right? Like the red blue once again.
Like for a physicist to look at this, for a chemist to look at this and completely ignore it, I believe would be completely foolish. This is something that really needs to be paid attention. There is very valuable data in what we're looking at right now, and we can't simply throw it off the sidelines.
Okay, so when going darker, you combine red and blue, you get purple. When going lighter, you combine red and blue, you get yellow. And when you combine red and blue with green, you get 3 dimensions. Explain that.
Modification of the local refractive index. Explanation complete.
That's the key thing right here. How lights, the color turns into the mass, like just so.
Well, in the original periodic table, and geez, I can't remember who the Russian researcher's name was, and shame on me for not pulling up his name immediately, but he had understood in his original deposition of trying to comprehend the elemental structure of all things that we know in this universal constant. Well, he had identified clear associations with the fractal structure of various elements, and was able to predict new elements that were not currently recognized based on their association within each other.
Yeah, based on this, Walter Russell predicted several, right? Gallium is...
Man, what I need to do is get some sleep. Good heavens.
Fascinating stuff. This is, the alchemy of these ages and the first sages from Thoth and electrolysis is the key to it all. And spinning water with 2 electrodes seems to be the key. PA, do you got... sorry, do you mind bringing up what you were working on there, good sir?
Oh yeah, I mean, you guys were just talking. I was just typing random phrases that you were bringing up and just rendering them out. Nothing specific.
Oh, I know. But it's magic. I love it.
So you were asking for like some alchemical symbols. So I was just searching for like alchemical Tesla laboratory, and then throwing in modifiers like Cinema 4D ray tracing.
And so what are your thoughts on this red blue shift? And green is like the neutral in some ways, but in other ways it gives you a 3rd dimension while still in 2 dimensions when you combine it with red blue. And then it's like purple is royal, but it's dark and heavier, yet...
Or are we talking about additive or subtractive color at this point?
Well, what about stereoscopy? You guys remember those red and blue glasses that you'd use for 3D images?
Yeah, that's what I'm talking about. That's why I'm exactly bringing this
Oh
up.
yeah, so then try adding stereoscopy or stereoscopic to the.
Oh yeah, there's actually a stereoscopic model that's trained to specifically do that. But if I just do stereoscopic and put that in, that should actually come out with exactly what you're talking about.
Yeah, there you go.
Right? And like it's fascinating stuff.
Well, it's been fun, folks. I'm gonna
colors
lay
are
down.
dimensions, and like the mass spectrometer, getting back to that, and that's literally deciphering mass out of the color, which is you get density from these lengths of waves of light that are what is it? Waves, photon. I don't even understand these ridiculous particle physics of like several dimensions, like imploded worth of just math that equals particle physics, I guess. But like
hey Bernie, I hate to cut you off, but I got to get up at 5.
Yeah, so Gerald, you've been extremely quiet, brother. Please share.
Well, you got a word. I got a word in here and there. That's all good. No, you've been busy, man. It's all good. Seriously. No, Jeremiah was saying he had to go catch some sleep, and I got to get up early in the morning. So I don't have much of an update for you because I can't show you anything. I wasn't expecting to come on tonight. Otherwise, I would have set up a demo. Working on my electric scooter. It's coming along just gorgeous. I took a permanent magnet alternator and turned it into a motor, and I'm using that as the motor for the scooter, and the scooter motor is what's charging a secondary battery bank while I run the scooter itself. So I'll have demonstrations for that hopefully this week. I'm waiting on the last battery, so we'll have to see about that. And other than that, I found a book that is apparently written by Enoch, and I've gone through just part of it, and so far he talks about the cubit that nobody can figure out, how it's 25 inches, or roughly, I think it's 24.5, somewhere in there. That's something I wouldn't mind going
actually like a quantum bit. Is that what it's going to turn out to be? That they're talking about a quantum bit the entire time? This measurement that nobody can figure out.
It's interesting. He goes into how the pyramids are built and stuff too. So I'm going to go through this book and then we'll have to like rip it apart and see if there's any truth to it. Maybe correlate it with some other stuff that's out there. Who knows? But that's basically my update. I appreciate you giving me the quick 5 minutes or 3 minutes or whatever it was. But I have to bail on you guys. It's good talking to you all.
Much love, brother. Understandable. It is 12:30 on the East Coast. Thank you for joining in. We'll do another Real Science very soon. And we got to do the Year of the Coil and the electroculture, which... so something that's kind of fascinated me is the electroculture like trend craze is just nuts, and like the 3-4x claims huge, and that it's in fact these solenoid copper coils, just like Keshi's pain pens and his Magrav capacitor coils, and that the claim is they have to be on the south side as the antenna into the ground, not the north side. And then a lot of people are claiming that they're supposed to be clockwise, and then others are claiming only counterclockwise. And now I've heard that certain ways depending on your hemisphere, which actually it's the exact same principles in physics that and field forces that Keshi has taught in his plasma systems and coil units the entire time. So it's kind of interesting.
Yeah, like if you're in the north, you're towards the North Pole, you use a South Pole wrapped coil, right? And vice versa. You would put it into the soil and allow that energy to accumulate into the soil. That's all it really is. It's basically an antenna.
Well,
how efficient is your antenna? That's the question.
Yeah, exactly. And so I wrap my antennas in a series of 9. So you've got that vortex harmonic of 9 and 9 in the coils, or in the symmetry geometry of it, as well as I go counterclockwise, because if the world is going clockwise and that's, time moving forward, I'm thinking energy moving backwards is where you're going to get your effects from, and this inverse vacuum, zero cold sourced.
Well, speaking of moving forward, I'm going to dip really quick here, but I'd love to. I'm going to put this out there. I have 550 subscribers. When I reach 1,000, I'm going to release all the information on how to build my coils with tutorials, the numbers, the templates, everything. And then everybody else out there gets to experiment and see the anomalies I've seen.
Hell yeah.
And take it from there. Take off with it. Fly, swim, whatever it takes. I'm just saying.
Build a death ray.
What I'm working towards. As soon as I hit 1,000 subscribers, I'm releasing it to the world. So
that sounds exciting.
I'm at 550 now, everybody. Do what you can. Jump on it. Let's get it out there.
And what's your YouTube channel?
Winnipeg Enlighten for Truth 2.
WPG Enlighten for Truth 2. And before you go, Gerald, finish that book on Enoch thoughts.
Well, there's not much to finish other than he goes into how the pyramid is actually, or what you see of it, all that sand, there's 100 feet down still of pyramid. And he goes into how the Sphinx was built and what it looked like before the flood. And there's some interesting details in there that I'd have to go over before I kind of spew them out. I don't want to get them wrong. So very interesting, but yeah, that we should be doing that the next science, the next real science. Or maybe sometime this week if you're doing, something on history or whatever. But either way, I got to dip out now.
For sure, man.
That's exciting, man. I hope we get you to 1,000 so we can see that soon.
We will.
Darn straight. And I'm going to release the how-to of the big coil, not the small ones that you see. That one, it's got some interesting effects that happen when you're playing with it. So that's the idea. That's what we're headed towards. Wish you all a good night.
I'm going to have to dip out as well. It's been a blast. Great talking with you all.
Yeah, likewise, man. Thanks for having me included. It was awesome talking to you guys. I'm dipping out too, so I think this might even be a good conclusion.
Exactly, a good ending. But
yeah.
PA, before you go, do you want to just show us a couple of those renders quickly? And that we're going to just have to do an Alchemy 101 episode soon here. And so you've done a lot of the occult esoteric readings on alchemy. So it's like you know all the references of like slaughtering the white calf or sacrificing the something color here, or animal, like, so the red lion, for instance, is this crazy super reactive state that they call the mercury state of transmutation metals.
Right, and all you have to do is add a little bit of heat, and then you can get the mercury right out of that.
Yeah, exactly. But like, I've literally turned aluminum to this red lion state and then rubbed it on copper, and they both simultaneously spontaneously combusted into flame. Like some crazy stuff that's happened in it. And like you said, you add heat, you get mercury out of it. But if you actually get physical mercury, like if this is turning into a mercury compound, but I'm making it out of aluminum and copper, well, that's transmutation of hard, heavy, solid metal, pure elements, and such things where you hear snake current, like a snake or bite or something like that in your readings. Think of that as like an electrical charge. The sulfur yellow is when you're cutting a charge or you've eroded through your anode, and then it kills this alchemy life reaction, and that it's talking about both current but energy. And it's like, this is where these gel super battery thingies of crystal, lattice, hydrogen or aluminum or whatever the bloody F. And it's like, it might turn out everybody can literally make this shit in a pickle jar with some fucking pennies and scrap wire and a silver spoon, and you've got metamaterials galore.
I got some of the images pulled up if you want to show them.
Oh, sorry, didn't see. My bad.
You were talking about monoatomic gold and lattice structures, so it kind of started out there. And then this turned into like awesome an aerogel powered Tesla coil, which doesn't exist, but it sounded like a cool thing.
I'm loving all of this, actually. Do you mind quickly, or I'll let you circle through all of them, and it was the gold at the very beginning. Look at these.
Yeah, these are aerogel lattice structures with Tesla coil prompts all kind of combined,
and many resembling freaking jellyfish weird creatures you see at the bottom of the
lattice. Yep, there's another lattice there.
And how it interprets geometry in these hyperdimensional geometries.
This is all red blue shift.
Right? Like, I think key physics and understanding that are not quite yet, and just we're on the brink of understanding new dimensions, but it's Pandora's box, so it's all insane and can't make anything of it until you have it all. But once you have it all, it's...
You were mentioning slime molds at one point and anodes, and then you mentioned combining your blood that was starting to like turn into an aerogel. So here's like some aerogel blood.
I like it. This is epic. I'm loving every single one.
It's kind of funny that we went from something really trippy at the beginning that was completely analog to something really trippy.
That's true. And I wanted to point something that Xirtus was saying a little bit earlier. That kind, I mean, the exact same analogy applies to these AI image models that he was talking about for the general ChatGPT models, where they're really great at being generalists and it can impress everyone at like its general knowledge. And that's sort of how some of these AI art systems work too, where they're really good at being able to do 2D and 3D and realistic and surrealistic and, you know, impressionist paintings. But you can also train a model, so it's just really great at making anaglyphs or those, you know, those stereoscopic 3D things. Or you can make one that is extremely skilled at just making alchemical symbols. So, like, for example, these are all supposed to be alchemical symbols, but it's not quite. I mean, you know, it has some of the shapes there, but it just keeps making like hexagons and certain like star shapes.
Right,
and
but that's what I find so fascinating, is how it interprets this like universal geometry of nature, and like what rules and limitations it has and the structure it takes out of it, right? It's just amazing.
What fascinates me beyond no end here is that, like, look at how it understands the refraction of the different materials and the lighting.
Yes,
light sources are consistent. That's something that's really hard to get right.
You just brought back to the point of what I was held up on the very first image of the gold sphere, and that I was looking at its proportions and where it put the shadows and stuff like that, and was like, what the, like, it almost looks like the shape of the like billion-year-old freaking rock sphere thingies that you find with like the dimple, or like the lines are like the disproportionalities, but they're called perfect. It's very strange. Needed a second look at it.
And it's funny too. I put in Tesla coil, and you can see there's like a little Tesla logo here, and then on one of the images, it's like an actual Tesla car.
but with like
it's so funny.
Arcs coming out the back into the ether.
Right? Yeah, because it's a Tesla coil.
So it's like, given the amount of Tesla symbols that it could be bombarded with, and just coming up with one of the logo, like, that's pretty decent discernment by it.
Even on this one, you can see the reflection of the object on the table there, and it's got that that blur to it, because it's not, a perfect mirror. It's being sort of diffused in a way from the material of the table.
Imagine when it has as many neurons as we do.
When it's working with the lost Babylonian qubit.
So that book that I showed a picture of earlier, anyone that wants to know about the history of measurements, that book, Our Ancestors Are From Outer Space, the guy was an archaeologist and loved math. And did he uncover some crazy stuff?
Can you please share it again?
Yes.
Reflection. Like, there was a pyramid and how it reflected in that one. Like, and like, see this one, look at that. Like, how there's like very strange how it shadowed. Like an apple there.
These ones were all supposed to be underwater. So cool. I love this stuff.
Oh, as do I, right? Like, our ancestors came from outer space and NASA. Oh, don't stop, Thomas. Don't stop. Oh, that was all of them.
That was all of them. Yeah, I went back all the way to the beginning.
For sure. Fair enough. And thank you all for being here. We are at 2.5 hours. That was epic. We're going to have to do this again very soon. And what I would like to do also with you, PA, is take like the different hieroglyphic and pictographic languages and geoglyphs or picture, all the ancient ones that are symbols basically and lost, and start entering them into the AI, just database and what it comes up with. And
I'm down, man. That sounds awesome.
Right? Awesome, brother. And let's see here. Did I put it on?
We'll transmute anything you want into some artwork.
What I'd like to see with artificial intelligence is give it like a plug-in card that's just an analog feedback system, so it can actually interact and build its own consciousness. That, I think, would be a good plug-in for artificial intelligence. But I don't think anybody's crazy enough to actually do that or would believe that would help them.
Well, that's when you have to hire the guy that just sits in the table next to the plug with his hand on it. So when he hears someone scream from the other room, he just yanks it out.
And speaking of plug, I need to plug everybody's channels before it ends, starting with Paranoid America. And how long have you now been restreaming and streaming to your channel since activating? Because you're doing quite well.
Oh, yeah, I don't know, man. It's probably been maybe a month consistently. So yeah, dude, props to Bernie for putting the ass, the fire under my ass And
Right?
like he just watched me like on a show somewhere else, and he'd be like, "What the hell are you doing? You need to
About
stream this to your
50
channel
times
right now."
already. But
And you'll see me post like 4 or 5 videos at once. What the hell are you doing? You gotta stagger them. So I love you, Bertie, man. Keep me on my toes, man. And
you too,
and
brother.
plug wise, we were talking about alchemy and sort of like arcane arts. I just dropped this homunculus owner's manual with Juan Ayala from the One on One podcast, and it breaks down the entire history of homunculi, and we even redefine a few different categories of homunculi. So there's the Crowleyan homunculus, there's a Paracelsian homunculus, but then we also we propose that there might be something called an Epsteinian homunculus, because Jeffrey Epstein was perhaps trying to repeat the Babylon working ritual that started with Aleister Crowley and then sort of evolved into Jack Parsons and L. Ron Hubbard's version of it. And then Epstein had some magic circles on his Zorro ranch. And yeah, here's some of that section here where it's talking about the Crowleyan homunculus, which he defines in one of his Libra books. Moonchild was one of the first examples of that. And when when Parsons and L. Ron Hubbard got together, they repeated the Babylon working, and Parsons decided that Marjorie Cameron was the Scarlet Woman. The Scarlet Woman was this homunculus that they kind of summoned from, like magical sources. And then, yeah, here's an example of Jeffrey Epstein's maybe a modern day continuation of that. We've got the corporate homunculus. There's so many cool little facts in here. And then it also shows you how you can make your own homunculus and what you can do with like its body and its blood. And you can grind it into like a powder and use it to, like repair trees and all kinds of cool stuff. And this is all completely backed by, old arcane texts. So it's not just like a completely fictional book. This is legitimately everything you could ever want to know about the homunculus, from practical to fantastical.
That's what I'm saying, though. Like, from all of like what I have learned and figured out from like the electrolysis and plasma alchemy and just the nuttiness of how advanced it really could be, and then seeing how like blood acts and like some snot that I put in, or just like hair. And it's like, ever since I first heard of like, oh my God, you're putting your semen into this, like it's literally just going to replicate clones of you, because I've seen it replicate cells of stuff before. I have not dared to like have relationships with my partner downstairs around my experiments anymore, just because I don't want to accidentally create a freaking homunculus, especially when I already have these like homunculus blood cluster thingies, or like, I'm gonna have to show like
well, that's the thing, is that you need even if you create a homunculus, you have to constantly monitor it, because if it gets too large or it lives too long, it's kind of like the golem story, right? If you forget to wipe the words off the golem's forehead, then he comes alive at night and he wreaks havoc. And it's kind of a similar thing with homunculi, but everyone is completely different. It depends on what kind of eggs you use. It depends on all sorts of different sort of variations in your formula. Right. And even people that are skilled alchemists, they don't like, you don't know what to expect. I was so
scared of it, I actually never listened to the full thing. Just I was like, I don't want to yet clone myself or fricks with this. And like the Epstein homunculus, it just gives me a shiver. Like, that is some evil freaking.
Well, because he was trying to procreate with like 20 different people at a time.
Yeah, he had like his cloning, grooming, weird ranches to top off everything else.
Can you explain the stripe? Like, what's with the striped building? Why the blue and white stripes?
Oh, so you're talking about the little St. James sort of like little palace?
Yeah, the little thing.
I mean, that one's across the board, but to me, it feels like a nod to like an old Crete culture, because it has that sort of that like aesthetic. To like, if you were to compare that to like old Crete temples, and if you look at the origin stories of Crete and the labyrinth, right, and the Minotaur at the center of the labyrinth, and what would happen is that the elites of Athens would have to to basically sacrifice their, bring their kids to the labyrinth and send them into this labyrinth. They were basically, giving their young to the bull god. So I really do think that original labyrinth, Minotaur, Crete, Minoan mythology that has this original basis in like elites giving up their offspring to honor the bull worship. And Epstein just had like a modern day nod back to that original, sort of like Phoenician, Canaanite, practices before the Romans drove it underground.
The dark arts of it, the demon part instead of the angelic light parts of it, and so here's the one part, like I heard like there's like the beating of like a dead horse or dog or something, stuff like that. And it's
that's Juan's favorite one. That's from the Liber Vacay, and it basically, you take a dog phallus and you beat a cow into a pulp until you pulverize its insides without breaking the skin. And
so what that's referring to is the cow being the egg of the mom and the dog being the sperm being inserted into the egg without breaking the cell of it to create it. No?
A little bit, although that particular recipe doesn't result in a homunculus. That particular one is how you create bees. So the concept
or beasts. Could
bees,
it be
like the little bees that fly around with stingers?
But I'm saying, could that be a mistranslation? Instead of bees, could it have been beasts, where you're, taking a donkey and a horse and you get the ass, or the tiger and the lion?
Well, see, it definitely could, because the Liber Vacay in particular, along with a lot of these old alchemical texts, they're the one of the longest games of telephone ever played. And because of the nature of the content that was inside the Liber Vacay, no one wanted to be caught dead with like these instructions written down in their library in public.
Yeah, exactly. Like that's what I'm saying. Like, so many of like the vilest practices were actually like encoding of like the craziest procedures. A lot of
like
times,
we're not creating millions of demons. No, they're just bees. You know what I mean? Like they didn't want to actually write what they were doing.
It's actually just pizza, guys. Okay.
But the phallus of the male into the cow, or like sire, aka pregnant womb animal, to create. We're gonna have to see the etymology and if it could be beast instead of bee. Mistranslation somewhere there. Or
well, one of the interesting parts of that, like regardless of what they thought they were creating out of it, they were fascinated with this idea of putrefaction, and a lot of them thought that like putricide, even if they didn't know that there was like a specific thing, that just that sort of transformation could be harnessed and used to transform not just healthy cells and living matter into dead matter that was then rotting away, but that they could harness that transformational energy and use that to create instead of let things just be destroyed.
So what's fascinating is that there's this level of like where in these electrolysis reactions, and when the metals are like alive and you're putting current in and then you end it, and that you like seal up the jar, and that it will create this sealed, everything will stop growing and moving and essentially like reach a neutral dead state, and then it will crystallize atop the water, between the water and the air, and like just freeze in this stasis. And then when you crack the air open, the lid open it, and then break into the water, everything becomes alive again. These monoatomics all start moving. It's like the craziest, weirdest stuff you've ever seen. And it's a lot of it's electricity, and I'm starting to suspect that literally you can grow any monster or homunculus or clone you want in your pickle jar with 5 volts electricity or the certain like battery AC input, and you might actually if you put the right matter into a egg and the genetic matters and keep it alive. From what I've seen with what happens to blood in this stuff in the salt water with electricity in the silver gold combo, and what I've seen with like both saliva as well as snot, as like just like the life grows and lives, and then it's like I've sealed it while in certain states where it like stays alive, but like in this stasis state in these jars now for like 10 years, where it's like my blood is like in every speck of water and still blood red as the day I freaking seal. Anyways,
It sounds like we're gonna make a booger homunculus at some point. I'm all for here for it.
But yeah, it's really nuts because you. Yeah. Anyways, it's for another day. This was epic, awesome, pleasure. Love you, Thomas. Love you, Simon, Sarah, Adam, Xirtus, if you're still there. Any last words, everyone?
Love you guys, man. Thanks for including me as always. I appreciate you.
It's been great. Have a good night, everybody.
Good night, guys.
Much love, everyone.
Love y'all. Catch you on the next one, probably later this week. Ta-ta.